In the last example, I looked at techniques of integration focused on the U-substitution. And these are the main formulas that I looked at. And again, I remind you that the U prime is du dx. So right here in formula number 5, instead of u to the n, if I replace the U prime by du dx, this becomes du, u to the n du, and you get your measuring power rule here for integration. So 6 through 7 or 6 through 8, I have it in terms of just du. Okay. In the last examples that I did, the U substitution was fairly obvious, but let me just clarify a few things here. When you're doing the U substitution, you're going to have something like this. The integral of, say, f, say some function. Now this format could be some function taken to a power, like x squared plus 1 to the 10th power, whatever. And then you're going to have a factor here that will be the derivative of what I have here. So it's a function of a function. So you have g prime of x dx. And the substitution will be obvious. You'll let u equal to the g of x. Okay? Because when you take the differential of that, it's going to give you g prime dx. So you'll be able to replace this portion right here, g prime dx, by du over here. Okay? So we have it here. And if you make the substitution here, this u, of course, is g of x, and this du represents the g prime dx. So now once you get in this format, then you're hoping it looks like one of these integrals. So if this f of u turns out to be 1 over u, then the integral can be obtained by 6. Natural log of absolute whatever the u is, plus a constant. Or if this f of u turns out to be e to the u, then again, easy integration, e to the u plus your constant. Okay? Or if it turns out to be a to the u, same thing. And of course you can have some trig functions also and do the same sort of thing. So for example, if you have the integral of, say, x e to the x squared dx. Okay? Same sort of thing. In this case, the g function is x squared. So notice if I take the derivative of x squared, I get 2x. Okay? So in this case, I would let u equal to x squared. So du would be 2x dx. Okay, so this x dx can be replaced by du over 2. Okay. So again, if you just have a constant in front of there, it's no big deal. You can still make the substitution, and this x dx gets replaced by du over 2, so this integral becomes e to the, okay, x squared is u. I have my 1/2 over here. Okay, and then this is du. And then of course now you just use this formula right here. Okay, and this is then 1/2. And the integral of e to the u is e to the u. Then you have your constant here times for 1/2, which is still a constant, so I just put it, instead of 1/2 c, I just leave it as 1/2 as rather c. And then you replace the u by what you started off with. So you always want the answer in the same variable, so this would be x squared here. Okay. So some of these are fairly obvious as to what the substitution is going to be. Look to see if you can find the derivative of that g function. If it appears as a factor here in the integrand, that'll give you an idea as to what to do. Sometimes it's not that obvious, and I do want to point out that there could be more than one substitution that would work. Try to look for the most obvious one. Okay, so in this one right here, again, and again, I remind you, always try to simplify your integral. So if you have something like, say, x times square root of x dx, you look at that and say, well, you let u be x, that won't do you any good. Let u be square root of x, won't do you any good. But see here, if you just simplify this, well, this is x to the first and x to the 1/2. This is just x to the 3/2 power. Now that becomes a simple integration, right? We add 1 to the numerator here, to the exponent rather. This is 5/2. And then we divide by 5/2, so that makes this 2/5 over here. Plus a constant. There you have it. Okay, so on this one right here, it's not really clear what to do. So you could say, well, you could let u equal to x. You could let u equal to, say, x minus 1. You could let u equal to the square root of x minus 1 and play around with it. But in order to simplify this the way we want to, here are the substitutions that we need. Okay. So we let u equal to the square root of x minus 1. So therefore, if we square it, square both sides, we get u squared is equal to x minus 1. And see, now that from there I can solve for x, so I get x is equal to u squared plus 1. And then the differential of this u squared here would be 2u du. Okay, derivative of x minus 1 is x, multiplied by dx, we have this, okay? So we can make these substitutions into the integral. Into the integrand, I should say. So we'll have then, this is going to equal to square root, okay, square root of x minus 1, that's going to be u, okay, and then x, I'll put it over here on this side, x, then using the substitution, would be u squared plus 1. And then the dx is replaced by 2u du. Okay, so again, this is u, so I made a substitution there, right here. And then the x is replaced by u squared plus 1. And then the dx is replaced by 2u du. Okay, so that's using these substitutions right here. U equal to square root of x minus 1. U squared then is equal to x minus 1, which means x is equal to u squared plus 1. And then dx is 2u du. Okay. Now this is fairly easy to integrate. We just multiply through, so this will be 2u times u squared, so this will be 2u to the 4th plus, okay, multiplying by 2u, here it's u, and then another 2u, that'll be 2u squared. And now we're just integrating with respect to u. Okay, so this is just basically polynomial in u, easy to integrate. So we add 1 to the exponent, that's 5, and divide by that, that's 5. So this will be 2 here. Same thing with the next term, add 1 to the exponent, that'll be 3, and divide by 3. This will give us 2/3 plus a constant. And remember, when you're doing these substitutions, always give your answer in the original variable. Okay, so here we go. So it'll be 2/5. And remember, u is the square root of x minus 1, so this is the square root of x minus 1 taken to the 5th power. Okay, square root is a 1/2 taken to the 5th power. This would just become 5/2 here. Same thing with the next one, plus 2/3. And then u is square root of x minus 1. Take that to the 5th power, or to the 3rd power rather. It becomes exponent of 3/2. Okay, so we have 2/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2, and then you have your constant of integration. Okay, and this is your answer. And of course you can do some simplifications. Okay, I've seen in some examples they might factor out a factor of x minus 1 to the 3/2 and simplify that. So always double check yourself. Clear this. Look at the next one. We have integral of 1 over 1 plus radical x dx. So again, you don't see the derivative of, say, g of x in this case, okay? But this is kind of similar to the first one. It's possible that you could let u equal to 1 plus radical x. You can let u equal to the square root of x, okay? One of those should work. And remember, the object is to transform this integral, so it's just in terms of u and du. Okay, try to simplify it because the way it's written there, it's kind of difficult to figure out what the integral is going to be. So here are the substitutions that I use for this one. U equal to the square root of x. Okay, and I do that because this allows me to eliminate the radical by just squaring this. Okay, just like in the previous one. Square both sides, I get u squared is equal to x, and then take the differential of both sides. It'll be 2u du, and then for x it'll be dx. Okay, so using these substitutions then, come up here and say this is equal to square root of, or the integral I should say, of, okay, so what do we have? Dx is 2u du. Okay, so this dx is on top, remember, so that can be replaced then by 2u du. In the bottom, I have 1 plus square root of x, but that's going to be u. Okay, so now here I have a rational expression in u. So all we simplify, we have degree 1 on top, degree 1 on the bottom, so let's try to reduce it. So simplify it using long division. I put this as u plus 1. And then we just divide. So u into 2u will be 2. And multiply here. This will be 2u plus 2. Subtract here. So these cancel out. This gives me a minus 2. And now I have to stop there because the degree of the remainder is less than the degree of the divisor. So I can write this as a minus 2 over u plus 1. So then this can be written as, replacing the 2u over 1 plus u by what I got here, this will just be 2 minus 2 over u plus 1 du. And now we just really integrate. You can break it up into two integrals, or you can just do it like that. Say, okay, this means the antiderivative of 2, or the integral of 2 with respect to u. Okay, so that's just 2u. Okay, and it's just in the form of 1 over u. The minus 2 is a constant. That doesn't matter. Okay, we have a formula for that. Okay, so we would use this as a substitution again. Change the variable, but anytime you have 1 over u, or 1 over u plus, where it's a linear factor, as long as the coefficient of the u is 1, it's always going to be the natural log. So this will be minus 2 natural log of what's in the denominator. Absolute value, be u plus 1. And then plus c. And then the last part there is simply to go back to the original variable. Okay, so over here u is a square root of x, so just make your substitution. This will be 2 square root of x minus 2 ln of, and then this will be square root of x, absolute value, plus 1 plus c. That's your answer. Okay. Okay, feel free to pause the video and rewind if you need to. I'm going too fast. Clear this here. Okay, the next one again, a similar problem. We have the integral of minus x dx over x plus 1 minus the square root of x plus 1. So again, you could play around with this. You get the pattern here when the examples have a radical. So generally, when you have a radical, you're going to let u represent, in a lot of cases, the whole radical. And depending on how it's written, it could be just the radicand here. But in this particular case, kind of like the last one here, I let u equal to the square root of x plus 1. Okay, I square it, and that eliminates the radical, which is convenient. So I get u squared equal to x plus 1. And then again, because I have an x over here, I say, okay, for x I can substitute, okay, solve this for x, I get u squared minus 1. Take the differential of u squared equal x plus 1, I get 2u du equal dx. So then with those substitutions, again, the objective is to transform this integral, the radicand especially, into an integral that simply involves the variable u. And hopefully it'll be one of those standard formulas that we can easily apply to solve the problem. So in this particular case, then, make the substitution for x so it's minus, and then x by this substitution is u squared minus 1. This is du. And then over here, x plus 1, from the substitution you see x plus 1 is u squared. So this can be replaced by u squared. X plus 1 replaced by u squared. and then of course minus, and then of course the square root of x plus 1, that's u. Okay, this is equal to so this is going to be then minus u squared minus 1 du. Okay. And the bottom is u squared minus u. So now I have a degree of 2 on top and a degree of 2 in the bottom. So I could use I could use long division to simplify this. But because I see this factors out, I'm going to factor out a u in the bottom here and make that u minus 1 times u. On the top, okay, if I leave the negative out here, I have a difference of squares. So this would be, say, u minus 1, u plus 1. Now, again, you could use long division here. Okay, write this as u squared and just multiply through by negative 1. Use long division, it's still going to work out. But anytime you can simplify like this, to me is better. So this u minus 1 cancels out, this u minus 1 cancels out, so I'm left with this right there. Okay? And then here I forgot, it was dx is 2u, so I need a 2, add 2u here, and right here this is a 2u, like that. So what am I going to have here then? I have left this u plus 1 and negative. Okay, remember this replaced this factor right here, so let me just mark this off here. So I have left then a minus, and then 2u times u, that's u squared, minus 2u squared. And then minus times 1, minus 1, then times the minus, the 2u, so it's minus 2u all over u. And then here, of course, I have an integral right here, and an integral right there. This is du. This is then is equal to, more simplification here, divide through by u here, I get minus 2u minus 2 du. Okay, now we just have a basic first degree polynomial in u. So adding 1 to the exponent and dividing, I get minus u here squared minus 2u plus a constant. Okay, now I just have to go back to the original variable. Okay, so u is the square root of x plus 1 here. So let me just carry it over here then. U squared is this squared, so that'll just give me x plus 1. And that's a minus in front. Minus 2, and u is the square root of x plus 1. And that's plus a constant. Okay, so this basically is your answer right here. You could multiply by the negative, minus x minus 1, minus 2 here, square root of x plus 1 plus your constant. Okay, So this gives you some more examples where the U-substitution is not that obvious, and you kind of have to play around with it when you plug these in and get it simplified as much as you can before you start to integrate. And I do want to point out to you, depending on the simplification, your answer might look different than somebody else's answer. Okay, depending on how you simplify. But this is your answer. Also, I want to point out to you, whenever you get your papers back from homework, especially a test, because a test counts a little bit more. Sometimes at universities, instructors don't grade their papers. They have a grader assigned to them. So they're going to make mistakes. Of course, an instructor also makes mistakes. So always double check your work, because sometimes you'll do a substitution and it's a legal substitution and your answer is correct, but because you used a different substitution than what the grader was thinking, or maybe the instructor, if he graded your paper, he might just look at your answer and say, oh, there's no way this is correct. And some instructors will grade you on right or wrong. If your answer is wrong, they don't give you any credit. Okay, so always look at your answer, and if you think you're correct, go back to your instructor. And that's happened to students. I know what happened to me when I was a student. I would always question the grading, and a lot of times other students also, they would go in there and point out what they did, and the instructor or the grader realized that your substitution, or the substitution that was used, did get the correct answer, even though it looked different than another substitution. Okay, so keep that in mind, and we'll see you in the next video. Thanks for watching.